Good day, learners! Today, we're gonna talk about light. It's a kind of energy that can travel through space in a form of wave. Light does not need a medium to propagate. It is a type of a transverse wave. A transverse wave is where vibration is perpendicular to the wave direction. The upper part of a transverse wave is called crest, while the lower part of a transverse wave is called trough. Now the distance from one crest to the next crest is what we call the wavelength, or from one trough to the next trough. It refers to how long a wave is. Now we also have amplitude, or the height of the wave. This time, let's find out how does a light travel. Light travels in straight lines. When you shine a flashlight or torch at night, you can see that light travels in a straight path. You can also observe that using a laser. And similarly, when you are in a car at night, you can observe that headlights shine on the things in front of the car, but cannot light up the things around the corner. And have you ever wondered how fast a light could travel? Light travels extremely fast. It travels at a speed of 3.0 times 10 to the power of 8 meters per second, or 300 million meters per second in a vacuum. Light travels faster than a sound wave, which only has a speed of 331 meters per second. The reason why lightning always comes first before a thunder. Light from the sun or flashlights looks white, but it is really a mixture of many colors. Would you believe that a white light is a combination of many colors? Well, it is. Now, what are the colors of white light? The colors in white light are red, orange, yellow, green, blue, indigo, and violet, or RGB, when dispersion happens. Now, what is dispersion? Dispersion is a kind of refraction which provided us colors of light. This phenomenon is observed when white light passes through a prism. A prism is a transparent optical element with flat and polished surfaces that disperses light. This is an example of a glass prism. When sunlight hits the prism, then dispersion happens. We can see that white light is scattered into its component colors, just like how a rainbow forms. A rainbow forms when there is a sunlight and a rain. The raindrops serve as tiny prisms that will disperse sunlight into its component colors, and that's gonna be the rainbow that we can see. At certain angles, at about 42 degrees, we can clearly see a majestic rainbow. Now let's talk about the hierarchy of colors of light. As you can see in the table, according to wavelength, it's violet that has the shortest wavelength and red has the longest wavelength. Now for the frequency, we can see that violet has the highest frequency and red has the lowest frequency. And as to the photon energy, we can see that violet has the highest photon energy and red has the lowest energy. Now let's define first what is a wavelength. It describes how long the wave is, the distance from crest to crest or from trough to trough of a transverse wave. Second is the frequency. It refers to the number of waves that move past a certain point in 1 second. Now the third term is energy. It refers to how fast the motion of the waves are. In a light wave, violet has the shortest wavelength, highest frequency, and highest energy. And red has the longest wavelength, lowest frequency, and lowest energy. This time, let's talk about refraction, the bending of light when it travels from one medium to another. For example, when you place a pencil inside a glass of water, you can see that the pencil is slightly bent. It seems like the pencil is broken, but that is just because of refraction. When light crosses the boundary of two media of different optical density, a change in speed takes place. Now, what is an optical density? It is the measurement of a component's ability to slow the transmission of light. A known indicator of the optical density of a material is the index of refraction of the material, denoted by small letter n. Now, what exactly is an index of refraction? It is a quantity that compares the speed of light in a material to its speed in a vacuum. Now let me show you the different refractive index of the different colors of light. As you can see in the table, violet has the highest refractive index with 1.508 and red has the lowest refractive index with 1.488. We know that the term refraction denotes to the bending of light. Since violet has the highest refractive index, therefore violet is the most bent color and red is the least bent color of light. Just like what you can see in a rainbow, red is the least bent and violet is the most bent color. So that's it. I hope you learned something today. Thank you so much for watching.